Okay, we're looking at infinite series this time. And an infinite series is something that goes on and on and on forever and ever. It doesn't have a termination point, okay? So an example of an infinite series is the following. Summation I starting at 1 to infinity, so sideways 8, of a sub I. So an example in algebraic terms, this would be a sub 1 plus a sub 2 plus a sub 3 plus dot, dot, dot. It never stops. Okay? An important question about infinite series is which series have finite sums? Oops, it should be an S. One way to determine that is to examine the sequence of partial sums. If the sequence converges, then its limit, and you're going to write this like this. They didn't give you very much room here, but it should say LIM of n arrow infinity.
Over or like up?
It's limit over n to infinity. And then it's a big S and a little n here.
No.
I know, there's not enough
Can you
room.
write that underneath?
So like this, I can write it in large form so you guys can see what I'm doing.
Like times S of n?
No, it's the limit of S of n. It's not really timesing it. It's the limit of this. Okay?
Limit of S.
The symbol for the limit, in this case, is S, and then it's a little infinity sign right here. Okay? So, I want to tell you some other formulas here, and this won't mean very much to you right now, but you can write them down. So, sum of an infinity series, that's what this is saying, is equal to the sum of I starting at 1 till infinity of a sub I. Does that make sense? Okay, so you're adding them all up to infinity, okay? Which is also equal to the limit of n as it approaches infinity of the sum of n.
So basically all three of those are the same thing?
Yep, which is also equal to, all four of them equal the same thing.
Is there only four?
Yeah, there's only four. Limit as n approaches infinity of the summation of I equals to 1 to n of a sub I.
That means the rest of it.
Okay?
And is the last one?
Yep, that's the last one. How can you tell if a series is an infinity series and it's approaching something? Well, look at this, you guys. If you have a graph, and I'm just going to put this little graph over here for an example. Okay, so I have this series here that's adding more to it, and it's just slowly approaching, and you notice that it's like finally converging to a certain number. And it doesn't seem like it's getting bigger and bigger. Okay, so this is an example of a series that's approaching a limit. Okay?
So that's an example of.
The infinite series of positive integers, 1 plus 2 plus 3 plus 4 plus dot, 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 is an arithmetic series. What is being added to each term here, you guys? 1, okay? The partial sums, S sub n has no limit. If you add all that together, it doesn't get smaller, it just gets infinitely big, right? It never approaches something like the one I just showed you on the screen.
Just over that.
Yeah, it just goes on forever. So this is true of infinite arithmetic series, except when a sub 1 is 0 for all I.
This doesn't even make sense. But okay. Is this one of those things that'll make sense later?
Yes, I know I'm giving you the definitions right now, and then you'll see how we get there later, okay? I'm sorry, it's kind of confusing in the beginning. All right, so for an example, Let's look at this activity down below. You're going to begin with the unit square here. This is S sub 1. Okay? And the shaded regions represents the sums S sub n for the first n terms. So the first one, I have half. It's just the green area is my area here, okay? The second term, I have 1/4. So if you look at this, it's 1/2 plus 1/4. So really, how much is that total?
Wait, 1/4 of the whole or 1/4?
Yeah, 1/4 of what's left.
That's half of what's left.
Oh, of the total. You're taking half of what's left, which makes it 1/4.
What is half?
You multiply by 1/2 each time.
Right. Okay, so look, the first one is just 1/2. To find my second term, I'm going to take half of a half, which is 1/4, and I'm going to add them together. Okay, so now I have 3/4. Then I'm going to take half of 1/4, which is this.
I feel like you're overcomplicating it. Can't you just say that you add you get like a half of the whole and then a fourth of the whole and then an eighth of the whole? I know, but what you're.
Yeah, but we're looking at this, and this is not an arithmetic sequence. What's happening each time? I'm multiplying the one before it by 1/2.
But it's set up like an arithmetic. Except you're not adding the same amount.
Right, it's not. So arithmetic means you're adding the same amount each time. This one you're multiplying by the same amount each time. Okay, so remember, arithmetic is adding.
Right, so then why doesn't it say 1/2 and then plus like 2/2 plus like a sub n minus 1?
Geometric is multiplying. Okay, hold on. Step 2 says write S2 as a fraction. So what is S2?
1/4.
No,
3/4.
3/4. Okay. S3 as a single fraction. How would you write that? 7/8. Okay. How about S4? It says draw a figure for S4. So let's do that. Yep.
Yay, Dory. I just don't like the square thing.
So really, that's S4, right? So S4 is 15/16.
Oh, and then I know what S5.
What would S5 be?
30.
Yeah, 30 seconds.
31 30 seconds. Okay, so it says find the pattern S1 through S4 and use the pattern to make a formula. So S sub n. What's happening with the numerator?
Is that an equal sign? Multiplying by
Yes.
2. And then adding
Multiplying by
2 plus 1.
Okay, it's multiplying by 2, but not plus 1. Minus 1. And then the denominator is 2 to the nth power. Because this is 2 to the second, 2 to the third, 2 to the fourth. Okay.
Wait a minute. So, if it's 2n minus 1.
Yep.
times-
I'm scared.
So 2 times 2 minus 1 is 3.
Wait, where did you get 2 times 2?
Because we're at S of 2, right?
and our n is
It's 4.
Yep. 4 minus 1 is 3. What is 2 times 3 minus 1?
7.
2 times is 5.
That doesn't work.
It's 7/8. No, because it's 2 times. 2
Oh,
times
wait. You know what it is? It should be, oh, you guys, I messed it up. This should be 2 to the nth.
Oh, yeah, that makes sense.
Okay, sorry.
I'm gonna say 2 times 3.
Minus 1 and you have 7.
Sorry. Okay, next page.
Everybody read that? It's not 2 times n minus 1. It's
2 to the n times 1.
What's your number?
As with sequences, if the limit as x approaches infinity of S sub n exists, the series is called a convergent series. And if the limit does not exist, it's called divergent.
All I remember from that thing is that Larry got it.
We should-
All right, so consider the following sequence. Consider the infinite sequence of 4 over 3, 8 over 3, 16 over 3, and then 2 to the n plus 1 over 3. It is geometric.
Wait, why? Because they're all being times 2?
Yeah, the top part's being times 2. Okay? Find the first 5 partial sums of the series. So that's what we're going to do now. So S sub 1 equals what? 4 over 3. Okay, S sub 2. Yeah, it's going to be 4 over 3 plus 8 over 3. Mm-hmm.
Wait, what?
It's adding the first 2 sequences, two in the sequence together. Okay?
Oh!
So this will be 12 over 3.
32 over 3 and then
S sub 3.
32 over 3.
Okay, so this will be 4 over 3 plus 8 over 3 plus 16 over 3
Why can't we just do 12? Oh my god.
equals 28 over 3. S sub 4. Same thing. Yep. Okay, we're going to take 16 times 2 to get 32, right? And then this will be 60 over 3. And then the last one, S sub 5. And then we're done with this little part.
Where does he get the 32 in the S?
32 right here? It's 16 times 2 is 32.
No, no, one above it.
64, yeah. I got 124 over 3. All right. My question to you is, does this seem to converge? Does it seem to be getting closer and closer to one number?
No.
You are correct. It is not converge. Okay. So we're looking, when we're doing this, we are actually looking at, we're looking at these numbers. Okay? It would be easier if we were doing a whole number, yeah.
Well, like, isn't it because we're going over 1?
Yes. Yeah, you remember that from last year. That's good.
No.
Oh, okay. Yeah, we're going to be talking about that in a minute.
I don't remember any.
So now, let's look at this next page here. We are looking at a theorem, and this tells us exactly what Juliana was telling us just a minute ago. Consider the infinite geometric series. That's important. Geometric series. S sub n equals g sub 1 plus g sub 1 times r plus g sub 1 times r to the second, and so on. If r is in between -1 and 1, the series converges. So if you're multiplying by something smaller than 1, it converges.
Can we go to an example?
Yeah, I will in a minute.
It's smaller used to explain things really easy, right? So you, in like simple terms, it's just.
So for example, if it were -3/4, is that in between those two numbers?
Yes.
Yeah.
Yes, so therefore it will converge.
Or 0.5.
Yeah, 0.5, it will converge.
So the negative
pi.
is these the
Will
number
not
that
converge.
multiply
Exactly.
Why is that?
Exactly.
And I was going to finish writing S sub infinity, the sum of it.
Is the negative 3/4 actually part of your sentence?
No.
No, I was just saying if 3/4, for instance, is between those two. Okay. So S sub infinity, that's an infinity sign, is the same as the limit, just like I told you earlier, of n approaching to infinity of S sub n, and here is the formula. G sub 1 over 1 minus r. Okay? Okay, so this is the formula that you're going to use to find the sum. Now, if r is greater than 1, say you have pi. If you're multiplying by pi, is it convergent or divergent? So this one is diverges. Oh, I put diverges. Diverges. Diverges.
The way you said it was so golden.
Okay. Does this converge or diverge? What do you think?
It converges.
Converges.
It's all under one. It's all under one and above.
It's asking you if it's a convergent geometric series.
Most
Yeah.
of it.
Yes. It's geometric because it always has by 3, and it's convergent because Yep. See, so it never gets.
Eh.
It's not approaching anything.
No,
guys.
you.
It's not approaching anything.
It's not a series.
It's not a series. Why? How do you know?
Oh, because the bottom is.
Oh, we're done. We're so done.
Nope. Why do you know this is not a series?
It's not changing either.
Nope. Nope. That's not why.
It's not adding.
What?
It's not adding.
Not adding. These are commas. It is not a series.
So it's a sequence?
It's a sequence. So this answer is not a series. It's not even possible.
So you
Here.
can have a limit on a sequence?
You can. It's just asking you if it's a convergent series, though.
Does it have to be adding or can it be subtracting?
It would have to be.
Okay, well, B is.
Yeah, it could be subtracting. It would be adding a negative number if you were subtracting, right?
F is not.
B is the same thing, it just has.
Okay, but now it's the exact same thing. Okay, yes.
So that means.
Well, since we're looking at these, we can automatically get rid of F then because F has commas, not additions.
Yeah, go with it.
Correct.
So then should we write not a series?
Yep. No. Letter F is not a series also.
Wait, when did we get to F?
She just was looking ahead and seeing. Yes, we are.
I was just saying that we can eliminate that.
Okay, so B. What is our R value? What's it changing by every time?
Multiple.
Okay, it is 1 because it just has.
Okay, so really, it's not timesing by 3, but timesing by 1/3, because it's the denominator that's being multiplied, right? Okay, so is 1/3 less than 1? Yes. So what does that tell you?
Convergent.
Yes, it's convergent. Okay. And we can find the limit of that convergence by taking G sub 1, which is 5/3, divided by 1 minus R.
Are we asked to do all this?
Yep. Okay. It says for those that could be, give the limit. I'm giving you the limit. Okay. So this is the same thing as saying 5/3 over 2/3. Okay. Now remember, when you're dividing by a fraction, it's the same thing as saying multiply by its reciprocal, right? Okay. So I went from here. This is the formula: G sub 1 over 1 minus R.
It equals 15 over 6.
Okay? So actually, the 3's cancel, right? So it's 5 over 2.
I never learned that one.
Here we have 640 plus 160 plus 40 plus 10. Okay? So I want to see what my R value is, and I can't really tell by looking at this. So what I'm going to do is take the second divided by the first. So R equals 160 divided by 640, which equals 1/4, which tells us what? It convergent. Yep, it's convergent. Yep, it's between negative 1 and 1.
And then the next one is
Yep, so, okay, so we're going to take G sub 1, that's 640,
Yeah, not the type of convergent.
minus 1 minus 1/4. 640 over 3/4. Oh, that should be 640, sorry. Okay, and then 640 times 4 over 3. Which is what? You end up with 2,560 over 3. Yep, that's the limit. Nope, it's the actual horizontal line. It's the y value.
What's that 256 number?
It's the y asymptote.
No, what is it? What number?
2560 over 3. Okay? So how about this one? This is arithmetic, so it's divergent.
Wait, if it's all like that,
Yep, arithmetic does not converge.
Wait, then why did B convert?
B is not arithmetic, it's geometric. Okay? E. What's happening on this one? What's my R value?
0.5.
It's a negative 0.5, right?
I don't understand what's happening here.
Well, because 10 times negative, 10 divided by 2 is 5, but this is a negative 5 here, so it's going to be 10 divided by a negative 2, right?
Why is it minus and plus?
Because this is already negative, and if I divide it by negative 2 again, it becomes a positive. And if I divide it by a negative 2, it becomes negative. Okay, so it will switch around every time if it's negative. Okay, so my R value is 0.5, which is the same as 1/2, right? So this one is convergent. Okay? And my possible value on this one is 10 over 1 minus a negative 0.5, right?
So 1 point.
Yep, so 10 over 1.5. So, yeah, so 10 divided by 1.5.
I'm wrong. Don't listen to me.
Yeah, so, yeah, you could just find the decimal value of that. Yeah, it's actually in fraction form, it's the same as 20/3. Okay. Okay, now G. What's my R value on this?
Wait, hold on. What happened to F?
We already found that one. It's a series because look,
-2.
not a series, I mean.
Well, over 1.
So R here is -2. So you're right, it's divergent. How about H? Yes, it is. Or 1/2. So it's convergent, yep. Right. Yep, 10 over 0.5,
Oh, wait.
which equals 20.
When did we do G?
Real quick, because we found that you're actually dividing by, or multiplying by -2 there.
Okay.
So -2 is outside of our -1 to 1. And so it's divergent.